Alright, welcome to this video. One of the most hated things in all of algebra, word problems. Alright, you might have been doing, you should already kind of have somewhat of a firm grasp on the solving systems of linear equations. We're going to move it into the word problems arena and see if we can figure out what's going on here. You'll see some patterns if you pay attention. Alright, why would I use this? Well, you never know when you're going to be on a deserted island and the only way to get off is to solve a systems of linear equations from a word problem. I'm just kidding. Anyway, let's move on to the real stuff here. Alright, North, the high school I work at, offers two different athletic event passes. In Plan A, you're going to pay $70 up front and $2 per event. Alright, so that's Plan A. Plan B, $13 in the beginning. It's not much, but $5 per event. So you can see that the plans you have to kind of choose, and it depends a little bit on how many things you think you're going to go to. If you think you're going to go to a ton of them, then pay a bunch up front and a little bit per event. But if you're only going to go to a few events, pay the little bit up front and maybe a little bit more per event, and it might come out a little bit cheaper. All right, one critical step in all of this is to define our variables. X, in this case, is going to be the number of events, and Y is going to be my total cost of going to events, including the upfront fee and the per event cost. All right, Plan A, I'm going to put over here, Plan B, so I'm writing two linear equations. Plan A, they wanted $70 up front and they wanted $2 per event. Notice the word per is going to go with the x variable. It's your slope. It's what's going to turn into your slope. The next one, Plan B, they want only $13 up front, and so we're putting that in the back. That becomes the y-intercept if you think about linear equations. And then the $5 per event, well, I'm going to put that with, when my board cooperates with me, I'm going to put that right here in front of the x. All right, so if I have 10 events, well, that would be x, because I said it was events. I would plug that in, 5 times 10, 50, plus the 13, $63. 10 events up here, times 2, 20, plus 70, $90. So in one of them it'll cost 90, the other one 63. So 10 events, I would go with Plan B. All right, well, let's see how this works. We're going to solve this using substitution of linear equations. All right, and here's the way I'm going to do it, is I'm just going to say, well, you know what, y equals 2x plus 70, y equals 5x plus 13. I'm going to take the 5x plus 13 and put it in place of the y over here. Or you could kind of say, well, I'm going to take the 2x plus 70 and put it in place of this y. Either way, I'm going to get rid of that y variable, which is causing difficulty because I can't solve for one of the variables when I have two variables in there. I can't get down to a number. So you see what I did is I basically put the two equations equal to each other, eliminated the y variable, and now I'm going to start solving it. I'm going to do minus 2x from both sides. I get 70 equals 3x plus 13. I'm going to subtract that 13 from both sides. I get 3x equals, what is that, 57. All right, and then I'm going to divide by 3, and I get x equals, I believe it's, no, it's not 21. Hello, Fisher. It is 3 less than that is 19. I don't know where I got 21 from. Anyway, so x is 19. This is, what I'm finding is the point at which these intersect. So I've got x equals 19. I need to now find the y, so I'm going to take this x and plug it into, I'm going to go stick it into this equation. Okay, so y equals 2 times x, but I'm putting 19 in there, plus the 70. I've got 38 plus 70, or 108. So this comes out to 108. So at 19 events, both of them are going to cost $108. Okay, so if you plan to go to 20 events, which one are you planning to go, which one, easy for me to say, which plan am I going to choose? Well, you know what, that's over that point of intersection. So I'm going to plug 20 into each one of those and find out which one costs the most. I plug it into this one, I get 40 plus 70, 110. I plug it into the other one, I get 100 plus 13, I get 113. It's plan A that I'm going to work with. Okay, so plan A in this case. The next thing, I have 35 coins, quarters and dimes. And we all know quarters are worth 25 cents and dimes are worth 10 cents. And for a total of $5.60, how many quarters do I have? How many dimes do I have? X and Y, I'm going to define them. I'm just going to go with quarters for X and dimes for Y. Could have gone the other way. It doesn't matter. Set up the equations. All right, one of my equations is going to be based on just total number of coins. The number of quarters I have plus the number of dimes I have equals not value, but how many coins. Well, I had 35 coins in all. In these coin kind of problems or ticket problems, you're usually going to have one simple equation that looks like that. X plus Y equals the total number of things that you've got. Now the value of coins, that can be a little more confusing. Now the quarters were worth 25 cents. So I'm going to multiply X, the number of quarters I have, times 25. I could put a decimal in here. I like to do it without decimals. Makes it a little bit simpler, I think. Plus, the dimes are worth 10 cents each, and I've got Y of them. I don't know how many. But in total value, okay, the total value is $5.60. Watch the little trick I put here. I left that decimal out. Instead of putting that there, because I left it out of the dime and I left it out of the 25 cents. If I put it in the 25, put 0.25 and 0.10, I need to put 5.60. I'm going to solve this just like we did before. No, I'm not. I'm going to do it with elimination. Okay. And let's see how this works. All right. So X plus Y equals 35. You know, it would be just as easy to solve this one for Y and make it into Y equals negative X plus 35. And I'm still going to do substitution. I could have done elimination by multiplying the top equation by negative 10, for example. In fact, you know what? And so I could have used substitution here, or I can use elimination with this one, and I'm going to multiply this equation by negative 10. And you'll see what I'm talking about in just a minute. Negative 10x plus negative 10y equals negative 350. Let's take the other equation and stack it underneath it. 25x plus 10y. Ooh, do you see why I chose negative 10? Look at those two. I'm going to eliminate that y variable. Equals 560. When I do that, I get negative 50. No, I don't. I get positive 15x. The y's cancel out to 0y. I don't need to write that. And then this comes out to 210, I believe. Is that right? 210. All right, that is right. Now I'm going to divide both sides by 15. I'm running out of space here. Dividing by 15. X comes out to, well, let's see, I believe 14. Okay, let me double check that in my head. Okay, 14, yeah, 14. So that means I have, whoa, wait a minute. X was quarters. I have 14 quarters, but how many dimes do I have? Well, if you look at this equation up here, 14 plus Y equals 35. It looks like I've got 21 dimes. All right, so that's $2.10 from dimes and $3.50 for the quarters, and it does add up to $5.60. I'm good on that one. All right, sorry that one took a long time. It's pretty complicated going through that kind of stuff. All right, so let's take a look at just two examples, and then I'm gonna let you work on your own. Logan, I'll go through them pretty fast. And you know, as always, if you want to pause the video, try them yourself. That's a great way to do it. If you get stuck, then play it up to that point, see if you're right, and then pause it again and continue to try it yourself. That's what it's all about. Logan's got two choices of DVD clubs. DVD Hut. All right, so this is DVD Hut. All right, that's my equation one. He charges $5 initiation fee, X and Y. And I bet that if I'm looking at this DVD, so if I get X is going to be the number of DVDs that I rent, and Y is going to be my total cost. All right, so the DVD Hut charges a $5 initiation fee plus $3 for every DVD. See how that worked out? 3x plus 5. $5 initiation, $3 per DVD because X is the number of DVDs. The next one is called DVD Company. The DVD Company. Oh, nice generic name for it, the DVD company. And they're charging, $2 initiation fee. Got to initiate you into this club, and then $4 per DVD. They're a little more expensive, a little less to get into it, but a little more expensive per DVD. So clearly, if you're going to, what we're going to find is the point of intersection. The point of intersection is going to represent the number of DVDs where the total cost for each company is going to be the same. Because they're both in Y form or slope-intercept form, I'm just going to simply put them equal to each other by removing the Y. It's officially called substitution. And then I'm going to solve. I'm going to subtract 3x from both sides to get the x on this side. I'm going to keep my x's positive because I'm not a negative guy. I try to avoid those negatives. Then I'm going to subtract 2, and I get 3 equals 1x, or just x. That worked out nice. Then I'm going to go back up into either equation, and I'm going to plug in that 3 for x. You see the one I did here was the 3x plus 5 one from the DVD hut. And I'm plugging in the 3 in for x, and I'm just going to simplify it. 3 times 3 is 9, plus the 5, y equals 14. Okay, so when is it going to cost the same? When you rent 3 DVDs, you're going to pay $14 for either company. So choose carefully. Now, on to the wonderful coin problems. Sam has 20 coins. Everybody's got coins. Coins in his piggy bank worth $3.80. Coins are quarters and dimes. Wow, just like the last one. They're throwing a little variety in there. If it had been nickels and dimes, we'd be working with 5 cents each and 10 cents each, but this one's quarters and dimes. System to represent this. How many quarters does Sam have? I was just asking how many quarters does he have, so I'm going to figure out both, but just answer the question. I'm going to go here, X, Y. I could have used Q and D for quarters and dimes. X and Y kind of sticks with our standard. It lends itself well to graphing. X equals, let's go with quarters for that one, and dimes for Y. And my board's going to slow down on me, make it look like I can't write. All right, quarters and dimes. So I told you earlier that there's always going to be one easy one. X plus Y, that's the number of quarters, the number of dimes. How many did he have in all? I lost it. 20 coins right up there in the beginning. Sam's got 20 coins. So there's one equation. Now quarters, there's 25 cents each. So I'm doing that. And 10 cents for each dime. And they had a total of $3.80. I am going to leave that decimal out because I left it out of the quarters and dimes. All right. Now let's do a little substitution. Earlier we did the elimination method. See which one you think is easier. Y equals negative x plus 20. I rewrote that first equation to get it into a y equals kind of form so that I can use substitution. So I subtracted x from both sides. Now I'm going to rewrite the second equation, 25x plus 10y, but instead of putting y there, I'm going to put what we said y was equal to over here, which is negative x plus 20, and then continue the equation, equals 380. So you see how I did a little substitution there. All right, 25x, what is the point of doing that substitution? Well, you'll see in a minute. I'm going to distribute this 10, so I've got negative 10x plus 200 equals 380. Now I'm going to simplify. I've got 25x and negative 10x all on the same side. I'm going to combine those like terms. That comes out to 15x plus the 200 and equals 380. Now I'm going to solve it just like you know how to solve equations. 15x is equal to 180. I divide by 15, and that comes out to 12, I do believe. All right, so x was the number of quarters. So I've got 12 of them. The question was, how many do I have of quarters, or Sam? And he's got 12. If I needed to find out how many dimes, I would plug 12 into either one of these equations. This is certainly the easier one. 12 plus what equals 20, and it turns out he has 8 dimes. So 80 cents, 300, yeah, that all works out. All right, so moving right along, it's time for you, if you haven't already paused it. Now, work these 4 problems. Maybe you want to print the, well, you can't print this out from here, but anyway, you got to write the answers down to these, show your work, and bring it to your teacher. Don't just write the equations, but turn around and solve it, decide if you can use elimination or substitution or some other method. You could even graph these if we wanted to, but that's probably going to be a little bit of a pain. But do that and check with your teacher, see if you're ready for a test or a retake. Thank you.